Good afternoon. In continuation of mathematical analysis of non-recursive algorithm, the second problem that we have in the textbook is this one, element uniqueness problem. Okay, so element uniqueness problem is nothing but we should check whether all the elements in the given array are distinct. Okay, so how do we solve this problem anta? After solving this problem we should find out the time complexity of the algorithm. Okay, so which is a non-recursive algorithm here. So let us analyze the given problem first. So we should find out the uniqueness of the element in the array. Now let us take one array like this. So here I have taken an array with the name A, and these are the elements of the array. 3 1 4 2 are the elements of the array, and it runs from the lower bound 0 until it reaches the value 3. So total there are n number of elements, I mean 4 number of elements. So here in the given elements I should find out, so there should be uniqueness in the elements. Okay, so one element should be different from the other element, or one should be distinct from another element. That is the problem. How do we solve it? The first method, I mean the solution would be like this. See, so what I do here is I'm going to take the first element of the array. Okay, so first element of the array can be accessed through a of 0. Okay, so the first element of the array is 3 and it can be accessed through a of 0. I'm going to check whether this is equal to the next element of the array, like this here. Okay, I'm going to compare a of 0, is it exactly equal to a of 1? Okay, so in this case a of 0, it is not equal to a of 1, condition is evaluated to true. Okay, so this is the true condition for me. Every time I should check the first value should not be equivalent to the other value of the element. Okay, because we are supposed to find out the uniqueness, no? So first element of the array is not equal to the second element of the array, condition is evaluated to true. Okay, and now check. So first element of the array, is it equal to the a of 0 is compared with a of 1. Now I'm going to compare a of 0 with a of 2, which means that 3 should be compared with 4, like this. A of 0, is it exactly equal to a of 2? No. 3 is not equal to 4, condition is evaluated to true. In the same way, I'm going to compare a of 0 with this element. Okay, so a of 0, is it exactly equal to a of 3? No, condition is evaluated to true. So this very first value, it is not equal to 1, and very first value it is not equal to 4, and the very first value it is not equal to 3. Okay, in the same fashion I am supposed to compare 1 with 4 and 2, 4 with 2, so that we can find out each and every element of the array is unique. Okay, so now let us go to the next element of the array. So now the value of I is been updated to 1. Okay, so a of 1, I should be checking a of 1, this one, a of 1, is it exactly equal to a of 2? Okay, 1, is it exactly equal to the location of a of 2? No, condition is evaluated to true. Okay, it is not equal, so we can move further. So now here in this case, a of 1, is it exactly equal to a of 3? So here in the a of 1 value, we have 1 and it is not exactly equal to a of 3, condition is evaluated to true. Okay, so now we are done with comparison of this one now. So in the first iteration what we did, a of 0 is compared with a of 1, a of 0 is compared with a of 2, a of 0 is compared with a of 3. In the second iteration what we did, a of 1 should be compared with a of 2, a of 1 should be compared with a of 3. So in the last iteration what we should do, we left with these two comparison. A of 2 should be compared with a of 3. So here 4 is not equal to 2, condition is validated to true. If the condition is true and also we reach the end of the array. Okay, like this. So now let us analyze this one. So to write an algorithm for this, we require two loops. Okay, so one for this one to keep track of this iteration, this entire iteration, and another to keep track of this entire iteration. Okay, so now let me take two variables called as I and j. Okay, so whenever we started with the 0th index value, no, so it is 0. So here you can observe I value I started with the index value 0 and it is ending at the index value 2. Okay, out of this tracing what we got is I value I started with the index value 0 and it has ended at the index value 2. Okay, which means that the iteration of I is this initialization of I would be 0 and we have to run through second value of the array. I mean second index of the array. So we should write one generalized equation for that, no? So we get 2 if we subtract n minus 2. So the total value of n is what here? Total value of n is 4. So what is n minus 2 gives us? N minus 2 is 4 minus 2 is equal to 2. Okay, understood girls? Because I value I started with 0 and it has ended at the index value 2. That's what it means. Okay, so 0 to 2 is nothing but it has started with 0 and it has ended at the index value 2. And that's why we have taken the upper bound as n minus 2. Okay, because it reaches only till here. I value, I loop reaches till here. Okay, it doesn't move forward. In the same way, let us analyze for the j, variable j. So here in this case, variable j is starting with it has the initial value 1. It has to start with the initial value 1 because 0 is starting at I is starting at 0 and j should be starting at 1 so that we can make the comparison of these two. Okay, that's why j loop is started with 1 and it is ending at the index value 3. Okay, which means that j loops run from 1 to 3. 1 to 3 can be written as j value 1 to n minus 1. Okay, so we get 3 by writing n minus 1. N is nothing but 4. 4 minus 1 gives us 3. That's why. Okay, so or else you can observe this pattern. For I value 0, we are performing 3 comparisons. For I value 1, we are performing 2 comparisons. And for I value 2, we are performing 1 comparison. This is how we get the values. Okay, by subtracting each of the value. So now you got, I think. I repeat once again. We require an array. So we require an array. Here I have taken the array size as 4. Size of the array is 4 and the elements of the arrays are 3, 1, 4, 2. I should check the uniqueness of the element. So what I do, I'll take a of 0 and I'm going to compare with a of 1. Okay, and I'll take a of 0 and compare with a of 2 and a of 0 compared with a of 3 in the first iteration. And then I increment value of I to point here and j to point to this location. And I value in the second iteration it has to start from 1. It will be compared with a of 2, a of 1 will be compared with a of 3. Okay, and again I'm going to move I value to point to this and j value to point to this. So I is now pointing to this location should be compared with this so that we have reached the end of the array. So that's why I loop runs from 0 and it will be terminating at the index value of 2, which means that you can take it as n minus 2. Okay, and your j loop, see, your j loop has to start from I plus 1. Okay, it has to start from I plus 1. Why? Because for the value of, for I value 0, it will run from 1, 2, 3. And for I value 1, it will run from 2. Okay, so when I value is 1, it has to, j value has to start from 2. How do we get value 2 at the j index value? So by performing this operation, j should be equal to I plus 1. Okay, when I value is 1, 1 plus 1, j will be starting from, I value is 1, 1 plus 1 gives us 2. So that j starts with 2. That's why we have taken the value I plus 1. If you take only 1, then your entire algorithm goes wrong. That's why j value has to start from I plus 1 time. Okay, and also in the second iteration you can observe here I value is 2 If I value is 2, it has to start from 3. How do we get that value 3? So we get value 3 by performing I plus 1. That is 2 plus 1 is equal to 3. Okay. If you take only j is starting from 1 alone, then it will be a wrong. Okay. So like this it will happen. So if you take only j value as 1, starting with 1. So for the first iteration, e of 0 is what? It should be compared with j of 1. That will be correct for the first iteration. E of 0 will be compared with e of 1. Will be true. And it will increment value of I. It will increment value of j. Sorry. In the second iteration, j value is 2. I mean e of 0 will be compared with e of 2. Correct. And in the third iteration also it gives the correct answer. E of 0 is equal to e of 3. It gives the correct answer. Okay. So when I value increases by count 1, when I value comes here, okay, when I value comes here, j value will be at the index value 1 again. If you take j starting with 1, okay, so j will be starting from 1 again. It will be wrong, no? In the sense, a of 1 is been compared with a of 1 again. Okay, that should not be happening, no? A of 1 value should be compared with the next element. Okay, so that's why we have taken I plus 1 rather than 1 alone. Okay, now let us write the algorithm for this. So the algorithm for this would be like this. See, so you know that I value starting from 0 to n minus 2, and j value has to start from the index value I plus 1 to n minus 1. For each of the iteration, we are performing e of I, is it exactly equal to e of j? Okay, if it is equal, we will return false because it should not be happening. Okay, both the values cannot be same. If it is same, then it doesn't have the uniqueness in the array. Okay, that's why. If this condition is satisfied, we will return false. If this condition is not satisfied, then we will return true, saying that there is a uniqueness in the array. Okay, and how do you find out the time complexity? We should write the sum for I loop. I loop is starting with 0 to n minus 2, and we should find out the basic operation. No? So for each of the iteration, we are performing one basic operation, that is a of I is equal to a of j. This we call it as a basic operation. Okay, and there is only one basic operation, and your j loop is starting from I plus 1 to n minus 1, that we have written. For each of this, we are performing only one operation. Okay, if we solve this one, it is n minus 1 minus I minus 1 plus 1. So upper bound minus lower bound plus 1 will be going to be this one. Okay, so we cancel out this 2 and we will be getting n minus I minus 1. Okay, and we should solve this one again now. So 0 to n minus, so we can split up like this. I value, whenever you get I, which is simply equal to n into n minus 1 divided by 2. Okay, for I value we have a standard equation, that is n into n minus 1 divided by 2. Wherever you find n, it should be directly replaced with n into n minus 1 divided by 2. Okay, so here you can make split up like this. So n minus 1 you can write this, minus I you can write, I mean this equation I have splitted like this. 0 to n minus 2, only one operation, so n minus 1 I have taken out here, and minus I have written here. Okay, because it is easy for us to solve. So now for this, how we can write? Upper bound is n minus 2. You should subtract it with the lower bound 0, and you should add the basic operation. Upper bound minus lower bound plus the basic operation into n minus 1. So this will be going to be n minus 1 into n minus 1 minus this one. Here you can put the direct value of I, n into n minus 1, but in place of n, you are supposed to update this value, this upper bound value. Here the standard equation for I is n into n minus 1, but so here we have the upper bound value n minus 2, so n should be replaced with n minus 2. So we will get in this format. Whenever you find in this format n minus 2 minus 3, we have a general equation for this, that is equal to n into n minus 1. We call it as arithmetic progression, no? It is n into n minus 1. So what is the higher order degree we get? N square, and that n square is going to be your order of, your worst case time complexity, or overall time complexity of this algorithm is this n square. Or else you can go for reducing this equation by writing like this: n square should be elaborated and this should be elaborated. After this we get something like this. Out of this we have the upper bound value n square, and that should be taken as the average complexity, average time complexity. That's it.